In this video, we're going to look at solutions. So a solution is a homogeneous mixture of two or more components. So you have to have at least two things to have a solution, but you could have more, so it could be 3, 4, upwards from there. The solute is going to be the minor component, and the solvent will be the major component of the solution. So a solution is equal to some solvent system plus one or more solutes. So if we had two things dissolved in solution, we would have two solutes. So if we think about a beaker and it's full of a solution, the solution is going to be this whole sort of component here, and then within that solution there will be some solvent and then some minor component, which is the solute. So the solute will be uniformly spread out throughout the whole solution. Solutions that have water as the solvent are called aqueous solutions. So we've written out chemical equations where we might say NaCl aqueous, and so when that's the case, we know that water is going to be the solvent and NaCl is going to be the solute. Let's fix that E there. When a solution is formed, we can categorize that solution either as an electrolyte or as a non-electrolyte. So an electrolyte is a solution that conducts electricity. And that happens, generally speaking, because there are ions in solution. And those can transport charge. So if we think about NaCl aqueous, what's really happening is that it's dissociating into Na plus ions and Cl minus ions, and those compounds tend to conduct electricity because they're ions. So generally speaking, ionic compounds form electrolyte solutions because they dissolve and dissociate into their ion components. So a non-electrolyte solution then does not conduct electricity. And those are generally molecular compounds. So compounds that have covalent bonds. So for example, glucose, which is C6H12, O6, solid goes to glucose C6H12O6 aqueous. So there's no ions, and so it's not an electrolyte solution. So generally speaking, non-electrolyte solutions tend to be molecular compounds, those compounds that have covalent bonds or polar covalent bonds, but where the electrons are shared instead of transferred from one element to another. A unique category of solutions are colloids. And colloidal solutions basically have suspended solute particles. So they tend to be a little bit bigger than a typical solute particle, and so they're suspended in solution, but they're not quite precipitating out of solution. So milk is an example of a colloid. So if we look at milk, it looks relatively uniform. You can't see through it, and that's a colloid. So you have fats and other compounds that are suspended in that aqueous solution that is milk. So one of the things that allows us to distinguish a colloid from a true solution is the scattering of light. So this first kind of clear, colorless glass is a true solution, so those particles are completely dissolved in solution. That second kind of opaque glass is going to be a colloid. So a colloid scatters light, and that's what allows us to distinguish it from a true solution. And it scatters light because of those big dissolved particles. So they're just too big to be completely uniformly dissolved in a true homogeneous mixture that is a solution. So when we think about a solution, in order to make a homogeneous mixture, the solute has to go into solution. It has to be soluble. So we can use the rule like dissolves like to predict whether a solution will form or not. But generally speaking, a polar solvent will dissolve a polar solute. So an example would be water, being a polar solvent, would dissolve an ionic compound where you end up having charged particles in solution because those would be polar as well given their charge. On the other hand, a nonpolar solvent like hexanes or oil or something like that would dissolve a nonpolar solute, like a hydrocarbon chain or something like that. Another factor that can influence solubility is temperature, and generally speaking, when the temperature increases, the solubility increases. So if we want something to go into solution, oftentimes we can warm it up and we can get more of it to go into solution that way. That's not true for all compounds. As you can see here for this sodium sulfate, it actually becomes less soluble as the temperature increases. But for most ionic compounds, as the temperature increases, the solubility increases. So we've been talking so far mostly about solutes that are solids and liquids, but you can also have gas solutes. If you think about carbonated beverages, for example, CO2 is a solute. Generally speaking, when you increase the pressure, then you can increase the solubility. So an increase in pressure increases your solubility of your gas. So if I apply more pressure to the liquid, I'll dissolve more gas solute particles into the liquid. Interestingly, gases are opposite of solids and liquids, so with a higher temperature, we have a lower solubility of gases. So one of these places that this is an issue is with the ocean. The ocean, as it gets warmer, will absorb less CO2, and it's one of our CO2 sinks. So as we have increasing global temperatures, we have less CO2 dissolved in our oceans, and more of it than is in the gas phase in the atmosphere. When you have a solution that has dissolved all of the solute particles that it can at a given temperature, that's called a saturated solution. If we heat up a solution, we can get it to dissolve more solute particles, and we talked about that previously. And then if you cool it down, what happens is it becomes supersaturated. And a supersaturated solution upon cooling will have those solute particles crash out of solution. So that's what this picture is, and I'll show you a video in class of a supersaturated solution where you can see it as a clear homogeneous mixture, and as it cools, you just get this kind of really intense crashing out of all of those solute particles, because as the temperature decreases, the solubility decreases, and so the particles can't be dissolved in solution anymore. So this is a picture of a supersaturated solution as those particles crash out.